Hello everyone, welcome back to the channel. In this video, I would be covering the road network design project which we would be making in C++ using the Kruskal's algorithm which comes under the greedy approach. In the previous video, I covered and made a basic README file in which I explained everything which we would be doing in the project. So in the last video, I gave a brief summary. In this video, I would be implementing the Kruskal's algorithm. In the next video, I would be applying the file handling part of the project. And in the next video, I would be using the tool GraphViz, which would help us visualize the graph. So let's get started. I would open my code blocks over here, and as you can see I have already initialized my main.cpp file in which I would be coding my Kruskal's algorithm for the project. So let's get started. So firstly I would include my bits slash std c++.h, the basic C++ syntax, and along with this I'll add a namespace standard, and I'll get my main function in the program, and the program would be ending with the exit code 0. Great, so we have a basic structure. Now I would be implementing the Kruskal's algorithm, and it can be divided into two steps. The first step is sorting the edges, and the second step is to if we have cycles, then we ignore the edge, and if we do not have cycle, then we take in the edge. Let me program and explain it further, and hopefully it would be clear. So let me define two variables here in number of nodes and number of edges which my graph contains. And basically in the graph, the node is my city and the road is the edge. So I hope it would be clear. If by chance it is not clear, please refer to my previous video to get an in-depth explanation on what we are exactly doing in the project. So after that, I would like to initialize or declare a vector in which I am taking uh, three variables. One is my start node, one is end node, and one is weight. And I would give it the name edges. Awesome. Now let me first. Okay, one more thing I'd like to add. In this project, I would be using a tool known as GraphViz. So in order to use that tool, I would have to uh, get the output of the minimum spanning tree of the Kruskal's algorithm in such a way that it can be put into a configuration file which is supported by the GraphViz tool. So I would be making the output in such a way that it matches the format of the dot file in the GraphViz tool. So in the main function, let me just first enter the number of nodes, number of edges, get, then I'll add the input, the format in which I would be printing my output. So if we see the documentation over here in the dot language, I'm trying to build something like this, in which basically this is the edge, this is one node, this is another node, and this signifies that it is a graph. So that's what I'm trying to do over here. The graph is over here. Great. After that, let me take a for loop, and in this for loop, I'm going to take my input. So some basic stuff. In this, firstly, I would have the first end. There is an edge. So in the edge, there are two nodes. So the first node and the second node. So this is end 1, end 2. End 1 refers to the first node, end 2 refers to the second node, and after that, my weight refers to the weight of the edge. Awesome. Now I would just get it inputted by the user, and 2 and my weight. Good. Now I have inputted all the information necessary for my edge, which would be a part of my graph, in which the node is my city and the edge is my road. So now what I can do here is I can push this. So edges dot push back, basically add this into my vector, this edge into my edges vector, and then after that I can add the weight, and along with the weight I can have my end 1 comma end 2. Great. Now, what can I do? Okay, so I have to continue with my format. So it will be something like this, I believe. This, and after that, so it was something like graph I have already made. Okay, node 1 is over here, then the hyphens, and then node 2. Okay, so my node 1 is over here, and my node 2 is over here, and after that I have, okay, now another thing I saw in the documentation itself is that in the attribute section I saw an attribute known as label somewhere here. Yeah, this is used for edges. It is a string and text label attached to objects. Okay, so basically I would try to add this label to my edge to depict the weight in the graph viz tool. And if there is any change regarding this, then I'll make it in the future in the next videos. Okay, so I have something like label equal to something like this. This backslash is for like including this quote, and these are the double quotes which are the strings which depicts the string. Okay, after that I want to have my weight over here, and after that I would have my double quote over here, something like this. Okay, great. Now I'll just put the next line over here. After this I can have my Kruskal's algorithm. Kruskal, let the function be Kruskal. Okay. And after that I can print out the end bracket over here to basically end my program. Okay, So I think this is good enough. This is basically added for ending this uh, with the graph portion which we started in the format. Okay. Now let's implement the Kruskal's algorithm. In the Kruskal's algorithm, firstly I'll have to add an algorithm to detect cycles. So let's first do that. So let me first declare a vector known as parent. Okay, great. After that, I can have a function known as find. Let it take something like x, and find basically what happens is that we are using the find union concept over here, in which uh, find is basically giving me the leader, and union is basically combining the leaders of the set. So that's what I'm intending to do over here. So parent of x, if parent of x is double equal to x, then I'm going to return x, else I'll return parent of x equal to find parent of x. Okay, so I think this is good. Next, let me make a function. Uh, let's say unite. Right? Unite is good. After that, you int x, int y, because I'm uniting these two, so that's why. And unite x and y, x equal to find x. Good. So basically, I'm finding the leader of x. Then I am finding the leader of y. After that, if the leaders do not match, then parent of x is equal to y. Awesome. Awesome. This is our basic implementation of Kruskal's algorithm. So let me make a Kruskal function over here, something like this. Awesome. And okay, so in the Kruskal's algorithm, I have to do two things. I have to first sort the edges vector, and after that, I have to basically select those edges which do not form a cycle. If an edge forms a cycle, then I am not going to select it, else I am going to select it. And I am going to select it in a way that I first select the edge with the least weight, the minimum weight. That's why this is a greedy algorithm, that I am always selecting the minimum weight of edge. And if it does not make a cycle, then I would be including it. And if it makes a cycle, then I would be discarding it. So that's the logic over here. So let's start with my Kruskal algorithm. So I'll first sort it something like this. Awesome. And edges dot end. Yeah, great. So I have sorted it using an inbuilt function. Okay. Now for int I equal to 1 and I is less than equal to my number of nodes, I plus plus. What I'm going to do here is I'm going to make parent at ith index equal to I. Okay. Now after this, I'm going to initialize a cost equal to 0. Okay. Now what can I do? I can initialize a vector over here which would depict my MST. So it would be something like this. What should I name it? MST. Okay. After that, if I iterate through the edges. Okay, so let's try iterating through the edges so that I can. It's already sorted, and now I have to iterate over the edges. So as I iterate over the edges, it would be selecting the edge with the minimum weight, and after that we would be deciding if it forms a cycle or not. So that's what we are going to do here. So something like for auto edges. So we are using the for each loop over here, and for edge in edges vector, let the end one over here equal to edge dot edge dot second dot first, I believe, and int end 2 is equal to edge dot second. Yeah, edge dot second dot first and dot second. Yeah, okay. So these are the nodes. Great. And one, my first node, and this is the second node. Okay. Now, after this, my weight over here is equal to my edge dot first. Great. Now I have the whole edge with me. I have both the ends and I have the weight. Awesome. Now, if I find that the leader of end 1 is not equal to the leader of end 2, that means it does not belong in the same set. Now, if it does not belong in the same set, then I would be uniting it. I would be taking its union and adding it in the same set with a common leader. Okay. Now, cost plus equal to weight. Awesome. Great. MST dot push back, and then end. How did I declare it? MST. Where have I declared the MST vector? Yeah, over here. So okay, it's a pair int. I declared it as a pair int. So nodes are basically I am taking in the nodes, which would be telling me which edge I am talking about. If I have the two nodes, then I know which edge I am talking about. Great. So MST dot pushback, I can enter my end 1 and end 2. Something like this. Okay. Now, now what can I do? So let's try basically printing out the minimum cost. So something like this, minimum cost, and after that I can have my cost and then yeah. Okay, now this is done. What else can I do? I can print out the edges. Okay, let's try printing out the edges. So see out edges in MST and something like this, and for auto edge MST, because I'm trying to iterate over the MST vector, I would print so my MST is containing my end1 and end2, and I want to print it in this format. Where is it? Uh, yeah, so here it is. This is my format. Okay, strict graph A B A B B A. Okay, great. Now what can I can do here is uh, see out edge dot first, then edge dot second, something like this. I believe. Great. Okay, so let's continue. What else can I do? Let's try running the program. Am I able to run this? Am I missing something? This is an error over here. Let's see. 'Cause this should be added over here. And is this working? Three, three, one, two, three, four, five, six, seven, nine, 10. Okay, so I added three over here. An end bracket is missing over here. Okay, so let's put the end bracket. Where is it? Was it missing? Uh, Let me just run it again. 2, 2, 1, 2, 3. Okay, so somewhere around here, I think. Okay, it should be somewhere around here. So 3, 3, 1, 2, 3, 1, 5, 6, 3, 4, 5. Yeah, so I think this is good enough for now, and I'll try to get the file handling portion in the next video. So this is it for today's video. I hope you got to learn something new. Uh, Please consider uh, following me and connecting with me on my GitHub, my Twitter, and my LinkedIn. And we can surely have e-coffee as well if you want. If we are able to arrange it. And so see you till next time. Bye.